Okay, hello, good morning everyone. Okay, so can you hear me now? All right. Okay, so today we will continue. Okay, uh, the next uh, topic. Okay, in chapter 5. Okay, so the fundamental of wave. Okay, so first we will see about the meaning of the period. Okay, so what does it mean by a period? So period is actually the time taken for one complete oscillation. So before I continue, I think I stop until here, right? Or this one I already explained to you. Last time we stopped until here, right? Okay. So the period, what does it mean by period? So period is the time taken for one complete oscillation. So let's say in the experiment, right, in the pendulum oscillation, okay. So the first thing you have to do, you have to take the let's say the pendulum, okay, and you go, let's say, to point A. So this is the example, okay. So I use no, not this one. Okay, so I just draw. Right, so this is the pendulum. Sorry. So this is the pendulum, okay? And this is the in equilibrium position, okay? And this is the, okay, so let's say if we drag from, this is A, B, and C. So let's say if we drag to point A, okay, and then it will oscillate to point B, then go to point C, then go back to point B, then go back to point A. Okay, so this is called as one complete oscillation. Okay, so the time taken for one complete oscillation, we call it as a period. So what is the time taken? Okay, from A go to B, go to C, and go back to B, and goes back to A. Okay, to its initial position. So this is called as a period. How many time taken? So they say from A, B, C, B, A. So the time taken is 5 seconds. So means the period is 5 seconds. Okay, so that's the meaning of the of period. So what does it mean by frequency? So frequency is the number of complete oscillation per second. So in 1 second, so how many complete oscillation that you can make? Okay, that pendulum can make. So let's say in 10 seconds, in 10 seconds, right, it can make like 50 oscillation. Okay, if 10 seconds can make 50 oscillation, so in 1 second, how many? So 50 divided by 10, so 5 oscillation. So this is called as a frequency. So mean in 1 second, okay, the pendulum will make a 5 complete oscillation. Okay, so you have to know the difference between the period and also the frequency. Frequency is the time taken for one complete oscillation. Okay, but for the frequency is the number of complete oscillation in 1 second. Alright, so I will give you a link, okay, peer deck link. Okay, and I want you to, for a moment, oh, not this one. So starting from this, okay, it's okay. So we just continue, right, sorry. Okay, so let's say for this one, right? So I say it says here determine the time taken to make 10 complete oscillation. Okay, so here it said the plasticine, right? The plasticine, okay, oscillate in 10 oscillation for 5 seconds. Okay, so 10 oscillation in 5 seconds. So for A means the time taken for 10 complete oscillation is 5 seconds. So the answer for A is 5 seconds. Or you can put 5S. Okay, for B, you have to determine the period. Okay, so you have to determine the period. So means the period is the time taken for one complete oscillation. So mean this one you have to divide. Okay, so let's check the answer for A. Is it correct or not? Okay. So okay, so this one the answer for A. Okay, so T is 5 seconds. Okay, for B is 5 divided by 10. Okay, so means for for one complete oscillation, it will make like 0.5 second. Okay, 5 divided by 10. Okay, so 0.5 second. Okay, for the frequency, you can just use the formula F is equals to 1 over T. Alright, so 1 divided by 0.5, you will get 2 hertz. Okay, so that is for the frequency. You can just use the formula as long you know the period here. Okay, so this is the answer for question just now. Right. So this is how he derived the formula. So F is 1 over T. Okay, so for D, it asks you to write an equation relating period T with frequency. So F is equals to 1 over T. So this is the formula. And the SI unit for the frequency and for the period is second and hertz. Okay, so what is equivalent unit for hertz? Okay, so because F is equals to 1 over T, right? So period is second, so 1 over S. Okay, so it should be S negative 1. So S negative 1 is actually equals to hertz. Okay, so the next thing you have to learn is what is the wavelength. Okay, so wavelength is the distance between two consecutive points in a phase. Okay, so it must be in the same phase, whether it's crest to crest or throw to throw. Okay, so let's say if I have a graph, right? If I have a graph like this, okay, and you need to find the wavelength. So the wavelength, this is called as crest, okay, and this one is called as throw. Okay, so if you want to find the wavelength, it should be from crest to crest. So this is the lambda. So lambda is actually the wavelength, or from throw to throw here. So this one is also called as a lambda, right? So this is for the transverse wave. Okay, so for transverse wave, you want to find the wavelength. So it's between crest to crest or throw to throw. Or sometimes, okay, you can find two semicircle. So two semicircle also is actually equals to lambda. Okay, so there are three ways to find wavelength in the graph. The first one based from the crest to crest, or throw to throw, or another one is two semicircle, right? Two semicircle is equals to 1 lambda. This is for transverse wave. Okay, transverse wave. So how about longitudinal wave? So for longitudinal wave, it's supposed to be from compression to compression. Okay, so for me this part, compression to compression, okay, or from the refraction to the refraction here. Okay, so this is called as 1 lambda. This is for longitudinal wave. Okay, so it's different. Longitudinal wave. Okay, so for transverse, okay, there are three ways you can find: crest to crest, throw to throw, or two semicircle. But for longitudinal wave, it's from compression to compression, or from refraction or refraction. Okay. Alright, so for this one, okay, you have to label. So it has here mark and label wavelength. Okay, so this one, this is called one wavelength. Okay, and this is also called as one wavelength. Okay, from throw to throw. And another one is from here to here, right? So from here to here also, we call it as the one wavelength. Okay, so this is for transverse. Okay, for longitudinal, okay, for compression, okay, so let's say from here, right, from here goes to here, okay, this is called 1 lambda, okay, or from here to here. So this is called a lambda. Okay, so you can see the line. The number of line also must be same. So let's say it's from second line here. So here also must be in second line. So that is equal as a lambda. Okay, from refraction, okay, from the first line here, must go from the first line here. Okay, should be in the same number of line. Okay. Okay, the next one is the speed of wave. Okay, so what does it mean by speed? Okay, so in chapter 2, we already learned speed is the displacement divided by time. Okay, so here also same. Okay, so distance traveled by a wave per unit time. Okay, so here it says the speed of wave, right, tells how quickly the energy which is carried by the wave is transferred. Okay, and the unit is meter per second. Okay, meter per second. So how many meter it travel in 1 second? Okay, so I will give you a link now. Okay, right. So can you please join? Okay, using the link. Don't answer anything yet. Okay, we have to wait for your friends. So there are 35 of you, right? Have you used this one before? Have you ever used peer deck before? Yes, okay. So means you are familiar already, right? So 3 more students. Two more. Anyone have a problem to use the link? Maybe your internet is not good. Three more students before I start the lessons. Two more. Anyone, if you're having a problem, can you please tell me? Okay, I give you 1 more minute to join. Okay, so means 3 more students is not here. Okay. Yeah, we just start. Okay, don't answer anything yet. Wait, come, there's already an answer here. Oh, okay. So some of you already answered the questions. Okay, start to answer the questions. This is actually okay. AEBF, AC, you don't need to shade the area here. You just put the answer here. Okay, you can type the text, right? Okay. Okay, very good. Some of you already got the answer. Okay, I give you like 30 seconds, okay, to answer. Okay, for question number 2 also you need to answer. Okay, so it says here based on diagram 2 you have to calculate the wavelength. So what is the wavelength here? 20 divided by 5 is 4. DE, BF, CG. Okay, so um, let's check the answer, right? Okay, so how you want to how you want to answer for this one? Let me check. Okay. So for this one, can you see your Google Meet? Okay. Okay, so here it says indicate the interval which represent one wavelength. Okay. So I already told you whether it's crest to crest, throw to throw, or two semicircle, right? So whether from B to F, okay, or A to E, okay, because two semicircle here, A to E, okay, and then C to G, okay, C to G also two semicircle, okay. This one B to F because crest to crest, and then this is two semicircle A to E, and then another one C to G also two semicircle. So this is called as the wavelength. Alright, so here it says you have to state the pairs of points which are at the same phase. Okay, so for the same phase, this one is B and F. Okay, okay, B and F, right? And also ACEG also in the same phase, okay, in the equilibrium. Okay, so ACEG also you call it as the same phase, or BF, right? Okay, BF, AECG. Okay, so this one is all is the in the same phase. Alright, so let's see for C. Okay, for C, ask you to state the direction of the propagation of water wave. So it says it start from A. Okay, so start from A, it will propagate to G. Okay, so start from A means it have to propagate unto G. So A to G means from the left to the right. Okay, so from the left to the right. Okay, correct. Okay, for this one, okay, you have to state, I have to calculate the wavelength. So you have to know this one from here to here, from line to the next line is called as 1 lambda. So here you have 5 lambda. Okay, so you have 5 lambda here. So 5 lambda is equals to 20. So lambda is 20 divided by 5. So you will get 4 cm. Okay, so that's the answer for the number 2 questions. Okay, so let's see for another one, the next one. Okay, some of you already answer, I think. Some got 0.8, some got 8 seconds. Okay, so some said the amplitude is 12. Okay. The amplitude is B. Six cm. Okay. So the 0.8, 12. Yeah, give 1 more minute. Okay, so let's check your answer. Okay, so it says here, okay, the time taken, okay, the time taken to oscillate 10 complete oscillation is 8 seconds and the distance AC is 12 cm. So AC is 12 cm. So how you want to find the amplitude? Okay, so how you want to find the amplitude here? So you remember, right, the before that we learned about the oscillation of the pendulum bob. Okay. Okay, so actually the amplitude is what does it mean by the amplitude? The maximum displacement from the equilibrium position. So let's say if I have A, B and C here. So the equilibrium position is B. Okay, so the maximum displacement is supposed to be A to B. Okay, so this is called as the amplitude. Okay, so B and C also we call it as the amplitude. So here means AB is A amplitude. Okay, and this one is also amplitude. So if I want to know amplitude, so me you have to divide by 2. So 12 divide by 2, so you will get 6 cm. Okay, not 12 cm. Okay, 12 cm is 2 amplitude. Okay, for one amplitude, only A, B or B, C. Okay, and for the frequency, for the period, okay, so it says here, so what does it mean by period? The time taken for one complete oscillation. Okay, so if 10 complete oscillation, okay, 10 complete oscillation is equals to 8 seconds, right? 8 seconds. So if I want one complete oscillation, okay, because period is the time taken for one complete oscillation, right? So if I want one complete oscillation only, I will divide by 10, right? So the answer should be 8 divided by 10, you will get 0.8 second. Okay, so that's the answer for B. And for C, this one we just use the formula 1 over T. Okay, so 1 over T means 1 over 0.8. So you will get 1.25 hertz. Okay, so that's the answer for number 3. Okay, so are you clear? Do you have any question? Because I noticed some of you said the period is 8 seconds. Okay, you have to remember period is only one complete oscillation. 8 seconds is for 10 complete oscillation. Okay, so are you clear? Do you have any question to ask? All right. So let's move on to the next one. Okay, so this one is a graph displacement time and also graph displacement distance. Okay, so displacement time and also displacement distance. Okay, so let's see here. It says here that the motion of an oscillating spring can be plotted on the displacement against time graph. Right? So actually there's a video here. Okay, so at point O, okay, at point O we call it as the equilibrium position. Okay, so mean if they are not oscillating, if it's not oscillating, it will stay at O. Okay, there is no force that acting on the slotted weight. Okay, all right. So when it start to oscillate, Okay, so when it start to oscillate, they say you drag to B. Okay, so means there is the amplitude here. So the graph should be go down like this. Okay, because you drag it to B. Okay, you drag the slotted weight to B. So the O will go to B. So start from the equilibrium position, it will go to B. Okay, and then after that, it will go back to O, right? Okay, and go to A. Okay, and goes to back to O, the equilibrium position, and go back to B. Okay, and go back to equilibrium position again, and go back again to A. Okay, then if this one we keep repeating until it stop. Okay, so when it stop means it's at the equilibrium position at O. Okay, so the graph will keep continue until it stop. Right, so here is the graph actually. Okay, so O is the equilibrium position. So A, the crest here, we call it as the amplitude. Okay, and the period here, is actually from equilibrium position here to here. Okay, two semicircle is the period. Okay, so this is for displacement against time. Okay, so I repeat again, from displacement against time graph. Okay, for displacement against time graph. Okay, so this is the graph. Okay, and this is the displacement. Okay, and this is the time in second. Displacement against time graph. So what the information that you can get? The first one is the period. So how you want to find the period? The period must be from crest to crest. Okay, or throw to throw. Also we call it as one period. Or we can say from here to here there is two semicircle. Okay, this one. This one also called as period. Same like wavelength also, but this one is the x-axis in second. Okay, so this one I repeat again, for displacement against time. Okay, the information that you can get, the first one is period. So how you want to find the period? Okay, so the length from crest to crest, or throw to throw, or two semicircle here, the distance. So this one is called one period or one complete oscillation. Okay, so based from the period, okay, you know you can find the frequency because the frequency formula is 1 over T. So you already know the period here, you just can substitute in the formula. So F is equals to 1 over T, right? Then you will get the answer for frequency. Okay, and another one that you can get the info here is actually the amplitude. Okay, so the amplitude. Right, so that is for the graph displacement against time. Okay, so remember three info that you can get from the graph. Okay, period, frequency, using the period. Okay, find the frequency, and another one is the amplitude. Okay, so in the wave there are two type of graph. There is displacement against time, and another one is displacement against distance. Okay, so you already learned for displacement against time. So the next one, okay. Alright, so I want you to try to sketch a graph here. Okay, I want you to sketch a graph. Okay, based on the amplitude that been given and also the period. So remember the amplitude is the crest, right? Okay, the height of the crest, okay, And the period you can find 2 semicircle. You can try from crest to crest or throw to throw. So it depends on your graph. If you start from the equilibrium position, means start from 0. So means you have to make like 2 semicircles. But let's say you start from crest, your graph starting from crest. So means you have to put crest to crest, okay, to get one period. Okay, and also you have to remember the scale here. You have to put also the scale for the x-axis. Is it hard to draw the graph? Yeah, if you use your mouse, it's hard to draw. Okay, let's see if we use a tab. Okay. Okay, so make sure you put the scale for your graph, right? Right. Okay, so let's see the answer. Okay, so actually how you want to draw. So mostly what I see, mostly most of you got it correct. Okay, most of you studied from the equilibrium positions. Okay, so here you label this one is the displacement. Okay, displacement. Okay, and usually in cm, and this one is time seconds. Okay, and then the next one you draw the wave. Okay, you draw a wave. Okay, so from here this is the amplitude. Okay, 5 cm. Okay, the period here is 0.4, right? So here should be 0.2, 0.6. Okay, and this is 0.8 and this is 1.0. Okay, so that is the answer. Okay, so this is how you draw the displacement against time graph. Okay, if you give you the amplitude and the period value. Okay, so let's move to the next one. Okay, so the next one is the displacement against distance graph. Okay, So displacement again distance graph. So what can you get info from the displacement against distance? Okay, for displacement against distance, okay. So let's say I draw the graph first. So this is the graph, right? Okay. So displacement again, sorry, this is, should be S, this one should be D. Okay, so the first one, of course, the wavelength, right? From here to here, two semicircle is the wavelength, or from crest to crest also one wavelength. Okay, so they say I add one more here. So this one throw, two throw also, we call it as one wavelength. So the first information that you can get is wavelength. Okay, and then another one what you can get is the amplitude here. Same just like displacement against time. Okay, you can get the amplitude. So displacement against distance also you can get the amplitude here. So that's the info that you can get based from this graph. Okay, so displacement against distance, only wavelength and the amplitude. But displacement against time, period, frequency and amplitude. Okay, so you have to know, you have to see first what is the x-axis here. Okay, before you say what you want, how you want to find wavelength or distance, wavelength and period or frequency. Okay, so you have to see what is the x-axis. Okay, so let's see the next one. Okay, so I want you to sketch a graph. Okay, for this one is a displacement distance graph. Okay, it give you the amplitude is 10, right? Sorry, the amplitude is 10. Okay, and the wavelength is 4. Amplitude is 10. The wavelength is 4. So let's see the response here. Okay, very good. Hmm. Okay, so let's check the answer. Alright, so it says here sketch a graph or displacement distance for a wave amplitude A is 10 cm. So mean the crest is 10 cm. Okay, so let me just draw the wave first. Okay. Hmm. Hmm. Okay, so this is 10 cm. Okay, so this is the displacement and this is the distance. Okay, so the amplitude is 10 cm, right? And the wavelength is 4 cm. So if you start from the equilibrium, so this one to this one, we call it as a 1 lambda, right? So should be here is 4. Okay, 4, 2, 4, 6, 8. Okay, so 2 semicircle is 1 lambda. Teacher, if I draw from here to here 4 cm, okay, so means if here is 4 cm, what is the scale here? Okay, so this one is 1.4 to 1.4, 1 point, sorry, 0.5, right? 0.5 to 4.5, right? No, 5, sorry, 5. This is 1 until 5. Okay, so you can still get the wavelength 4 cm. Okay, so that's the how you want to draw for the graph and this graph of displacement distance. Okay, so let's see the next one. Okay, so now they give you a graph. Okay, they give you a graph. They ask you to determine the amplitude, the period, the frequency, the wavelength, and also the wave speed. So the wave speed is V is equals to F lambda. So I give you the formula here for the wave speed is the V is equals to F lambda. Three second, 3 cm, A3 T is 0.55, F is 1 point divided by 0.5 to hertz wavelength. Okay, so you have to know which graph you should take for period, which graph you should take for wavelength, okay, and which graph you should use to find the frequency, okay. For hertz. Okay, so let's check the answer. Okay, so I saw some of you got it correct. Okay, 0.5, 16, 0.5. Okay, 0.5, 2 hertz. Some of you got 4 hertz. Okay. Okay, for the amplitude, you can take whether displacement against time or displacement against distance. So both also same. Okay. So the amplitude is 3 cm. Okay, so I just write the answer here. So this one is 3 cm. Okay, for the period, you have to take displacement against time. So one period is actually equals to 2 semicircle. Okay, so means from here to here, that is 0.5. Okay, so the period is 0.5 second. Okay, how about the frequency? So frequency, you just use the formula 1 divided by 0.5. So you will get 2 hertz. Okay, so the frequency formula is 1 over t. So the period you already find just now. So you just substitute in the formula 1 over 0.5, you will get 2 hertz. Okay, so this is the answer for the frequency. So how about wavelength? So wavelength is the two semicircle, but this one you have to use you have to use the displacement against distance. Okay, so I take two semicircle. So the answer should be 16. Okay, so 16 cm. Okay, then after that, if you want to find the wave speed, this V is equals to F lambda. Okay, so the frequency is 2. Okay, the lambda is 16. So you will get 32 cms negative 1. Okay, so don't forget to put the unit every time you calculate something. Okay, so 32 cms negative 1. So this is the wave speed, right? Okay. So let's move on to the next one. Okay. So this one you have to find the frequency. So how to find the frequency? This is the displacement against time. Okay. So how you want to find the frequency? 0.25. Okay. Remember, don't give answer in fraction. Okay. The answer must be in the decimal. Zero period 4 second. Okay. Okay, so mostly all of you got 0.25, right? Okay, so let's check. So this is displacement against time. So frequency is F is equals to 1 over T, right? So the period is 2 semicircle here. So this is 4 seconds. So 1 divided by 4, you will get 0.25 hertz. Okay, so this one is easy. Okay, so before I move on, is there any question you want to ask teacher? No? So far, can you understand how to find wavelength, frequency, amplitude? period, okay, how to calculate the speed, how to draw a graph, what is the difference between transverse and longitudinal. Okay, very good. Right. So next, we move on to the next question. So here, asks you to find the amplitude, period, frequency, and wavelength. And I add another one. Okay. There is a wave speed here. Okay. So for E, you have to find wave speed. Okay, so the formula V is equals to F lambda. Okay, so remember V is equals to F lambda only for the wavelength speed. Okay, so you don't use in the linear motion like that. For linear motion cannot use this one. You have to use V is equals to S over T. Hmm. Okay, so I see most of you already got the answer. Okay, wave speed cm as -1. Okay, the unit for wave speed. Hmm. Pukul 1.
Cikgu nak makan kacang. Cikgu buat kacang tu lampu.
Itu tak kisah. Cikgu tak kisah.
Ayah ada okey tu kan.
Okay, so let's try to see the answer. Okay, for the amplitude, right? So the amplitude is 0.5 cm. Okay, so 0.5 cm. Okay, how about the period? So for the period, you have to use this graph, okay, because it's displacement against time, okay. So you have to use this graph. So we take two semicircle here. So the period is 0.4. Okay, so for the frequency, F is equals to 1 over T, right? So 1 divided by 0.4, you will get 2.5, I think. 0.4, so you will get 2.5 hertz. Okay, and then how about the wavelength? So for the wavelength, we take the displacement against distance. Okay, so from here to here, still two semicircles. So the lambda here is 2 cm. Okay, so now the wave speed, so V is equals to F lambda. F is 2.5 and the lambda is 2 cm. So 2.5 times 2 is 5 cm as negative 1. So that's the answer. Okay, so very good. Okay, so let's move on to the next one. Okay. Right. Okay, you have to compare. Compare the frequency, compare the wavelength, and state the relationship between frequency and wavelength, and then you have to draw the graph. Okay. So which one it has the higher frequency? A or B. So if you want to see the frequency, you can see the graph, right? So if the graph is much closer to each other, so let's say from crest to crest is much closer to another diagram. From if you compare with another diagram, so means the frequency is higher. Diagram A has a higher frequency, diagram B has a higher wavelength. So what is the frequency and the wavelength relationship? Inversely proportional. Okay. Alright. For this question, you can say inversely proportional or you can use the graph. Okay, inversely proportional or you can say the higher the higher. But in graph, if they ask you the relationship of the graph, okay, make sure you use the inversely proportional, directly proportional or increasing linearly. Don't use higher higher. Okay. This one for relationship is okay for use the relationship of graph. A is bigger. Okay, so bigger is actually for size. Okay, like size of balloon. Okay, size of balloon. You said bigger. But if you say you want to compare the magnitude, you use higher or lower. Okay, that's if you put this one. Okay, if you get a very strict, okay, very strict teacher, okay, to mark your exam paper, so this one should be wrong. Okay, so it's okay because we don't know who's answered this one, right? Wavelength is longer than the wavelength. B is longer. Higher, yes, very good. Okay, alright, you can still use this one. But I'm not sure because there's some rumors said, okay, I've been heard like someone said maybe after this they want you to answer in complete sentence. So any symbol are not allowed. Okay, so for me personally, I like I like you to answer in sentence. Okay, as you know, because every year they keep changing the marking scheme. Okay, so in order to we play safe, right, we put the complete sentence. Okay, so there's no way that we deduct your marks. Okay, what is this? A has higher, B has, A has higher, B has inversely proportional. Okay, in exam answer in complete sentence. Okay, don't put like A has higher what, B has what. Okay, this one is okay, inversely proportional. So maybe I understand it's hard for you to write using mouse. Okay, but in exam answer in full center. Why not you using the text? Yes, the symbol T, right, at the bottom of your desktop there. Oh, okay, at your screen there they have word T, right? So you just click that one and you can write, you can type anywhere you want. Inversely proportional, 6A have higher frequency than 6B. Okay, frequency of graph A is higher. Okay, inversely proportional. Okay, inversely proportional. The wavelength of B. Okay, so mostly of you got it correct. Very good. A lower than B. Maybe after this we can try to answer AC question, right? Okay, very good. Okay, so mostly all of you got it correct. Okay, so let's check the answer here. Okay, it asks you to compare the frequency. Okay, the frequency between diagram A and B. Diagram B. Okay, so what you have to do is, okay, so frequency, okay, frequency in diagram A is higher. Okay, so what is the wavelength? Which one has the longer wavelength? So 6B, right? Wavelength in diagram 6B, B is higher. Okay, so what is the relationship? So some of you say inversely proportional. Okay, some answer the higher the wavelength, the higher the frequency, the lower the wavelength, or the higher the wavelength, the lower the frequency. Okay, both also can. Okay, so let's say if I put here, the higher the frequency, the lower the wavelength. Okay, very good. Okay, then how about the graph? Okay, so based for the formula, right, V is equals to F lambda. So means here if I change the position of lambda, if I put like this, V over lambda is equals to F. So let's see if I increase the frequency, the lambda will become decrease, right? So means this is the inversely proportional. Okay. So you have to draw like this. Make sure it will not cut off the x-axis. Okay. So it should be like this. Okay. And for the F against 1 over lambda. Okay, so this one, if you change the graph to 1 over lambda, okay, the axis to 1 over lambda, it will become directly proportional. So this one we already learned in chapter 1. Okay, so very good. Okay, so we move on to the next question. Actually, this one we already learned. Wait for a moment, I erase first. Okay, here is said, all right, the relationship between the speed, wavelength, and frequency. So, ask you to name, right? Name the distance between two successive crests. So, this one is a lambda, okay, a wavelength. Okay, and then the time taken to travel between two successive crests, this one we call it as a 1 period. Okay, and then after that, you have to know V is equals to S over T, right? Okay, and the period is 1 over F. Okay, then you can derive the formula. You will get V is equals to F lambda. Okay, so this is the formula that we used just now. Okay, V is equals to F lambda if you want to find the speed of wave. Okay, switch on the motor to start the vibration with low frequency. Increase the frequency by increasing the voltage. So this one, if you use a ripple tank, okay, then you have to observe the pattern on the white paper. So by using the stroboscope. So if they ask you what is the function of the stroboscope here, so the function of the stroboscope is actually to freeze, okay, to freeze the wavelength. Okay, to freeze the wavelength. So if you see using the stroboscope, you can find, okay, what is the wavelength here. You can calculate what is the wavelength, okay, measure using your ruler, okay, the wavelength here. So what is the function of stroboscope here? To freeze the wavelength. Okay. Right, then we move on to the next one. Okay, so here it said draw a pattern for low high frequency of the motor. Okay, so draw a wave pattern. Okay, so this is the low frequency, this is the high frequency pattern. So here I want you to write, okay, so what will happen to the lambda, what happened to the frequency, and what happened to velocity if you change from the frequency from low frequency to high frequency. Okay, so try to answer this one. What will happen to the lambda? So the lambda is actually from here to here. This is called as 1 lambda, right? From red to red means same phase. Okay, blue to blue, one same phase. Okay, so maybe this is a crest throw. So from lambda is from crest to crest. So if you compare the distance, what happened to the distance of the lambda? Okay, so correct, lambda will be decrease. Okay, lambda will be decrease. Velocity, sorry, frequency is increased because you change from low frequency to high frequency, right? So mean the frequency will increase. Okay, so the velocity, okay, V is equals to F lambda. So what will happen to the velocity? Increase, increase. Increase, V is equals to F lambda. Lambda V is equals to F lambda. So when the F increase, okay, so let's check the answer. So here the answer should be the lambda is, you can see the lambda is decreased, right? So here is the lambda. Okay, so here is the lambda. Okay, and here is the lambda. So you can see it become smaller. So this one is decrease. Okay, so the F is increasing. So F V is equals to F lambda. So if F is increasing, the velocity also increasing. Okay, so that's the answer. Okay, so let's see for another one. Okay, last one before we stop. Okay, I want you to answer for number 1 and 2 only. It says here, calculate the frequency of water wave with the wavelength of 4 and traveling at the speed of 1.6. So this one use V is equals to F lambda. Okay, so let's say let's try to answer for this one. Okay, this one for question number 1, right? So it says here calculate the frequency of water wave with the wavelength of 4 cm and traveling a speed, okay, at the speed of 1.6 cm second. Okay, so V is equals to F lambda. Okay, so the F here is you need to find, okay, V is 1.6, lambda is 4. Okay, so 1.6 divided by 4, you will get 0.4. Okay, 1.6 is the is the speed. F you need to find, lambda is 4. So 1.6 divided by 4, you will get 0.4 hertz. Okay, and then for number 2, it said before a concert start, a musician tunes his guitar string to note A, okay, to note A, which has a frequency of 440 hertz. So 440 hertz. What is the wavelength? What is the lambda? Okay, if the sound wave produced by the guitar string, if the speed of the sound in the music hall is 340 meter per second. So again, V is equals to F lambda. V already give here 340. Okay, and the F is 443. And you find the lambda here. So the lambda is 340 divided by 440. 340 divided by 440. So you will get 0.77 meter. Okay, round off to 2 decimal point. Okay, or you can take 3 decimal point also can. Okay, so can we just finish one more? So this one I just discussed. Okay, so this is the amplitude, right? So the amplitude is 10 cm. Okay, and for B, okay, the period is, okay, 2 semicircle, right? So it should be 0.4, okay, second here. Alright, and the frequency, you just use the formula 1 over T. Okay, so T we already know 0.4. So 1 divided by 0.4, you will get 2.5 hertz. Okay, so any question you want to ask before? After this, we'll move on to the damping or resonance. Okay, and then after that, we go to the reflection of wave. Okay. So I hope you are clear about this one, okay, for the 5.1. Okay, so if anything, you can text me. So I see you on Thursday, okay? So take care, class. Okay, stay safe, all right? So bye, everyone. Okay, thank you for your cooperation. Bye.